Hi, my name is April Leachman and I teach at East Paulding Middle School in beautiful Dallas, Georgia. And this is NASA Now.
What that does on the asteroid is the astronauts read out the gravitational effect of those planets.
Hi, I'm Dan. You're about to see one of NASA's coolest tools in expanding our knowledge of the universe. It's called SOFIA, and you won't believe what this aircraft can do and the incredible technology inside. That's ahead. First, here's what's happening at NASA now.
The James Webb Space Telescope gets its wings and is one step closer to liftoff. Scheduled for launch in 2018, the James Webb Space Telescope will soon be ready for testing as the assembly of its support structure wings is now complete. The telescope's wings are part of a massive backplane that will hold the structure's primary mirrors in place. The wings will also allow the telescope's 18 beryllium mirrors to fold up and fit into a 16-foot fairing on a rocket. Once in space, at 1 million miles away from Earth, the 14,000-plus pound telescope will deploy, reaching the height of a 4-story building. The James Webb Space Telescope will be the largest and most powerful telescope in space. Using infrared light, it will allow astronomers to see through dust and gas clouds, and this will help us provide a detailed view of the most distant, never-before-seen objects in our universe.
In today's program, we'll talk with NASA research pilot Manny Antimisiaris, who flies the world's largest airborne observatory. The aircraft houses an infrared telescope capable of making observations that are impossible, even for the largest and highest ground-based telescopes. Manny will share the awesome responsibility that comes with flying this one-of-a-kind aircraft. He'll also discuss the amazing features of the telescope.
SOFIA is a modified 747 SP. Over a 10-year period, the aircraft was stripped down, modified, cut up. Big giant telescope that weighs approximately 45,000 pounds was inserted in the back half of the aircraft. A lot of instrumentation and computers assigned to that airplane. And our job is to basically fly above the Earth's atmosphere, anywhere from 35 to 45,000 feet. And the door opens in flight and the telescope gets a very clear picture, an infrared picture of the objects that they're looking for. Primarily the advantage is with this telescope that we are above 98% to 99% of the Earth's atmosphere and moisture, and it gives the astronomers a very clear picture of deep space. We're looking at the formation of planets, the formation of galaxies, the formation of new stars, but we also have the capability, which is unique to SOFIA, of doing what we call an occultation. That's when a star and a planet line up and the shadow is cast on the Earth's surface. We have the capability to fly to where that shadow is going to fly over us and capture that image. We actually did that last year, where a star and Pluto aligned and the shadow was cast over the middle of the Pacific Ocean. It was only a 120-second window. We were able to fly out there, capture that image, and then fly home. That's a capability that's unique to SOFIA, and even Hubble doesn't have that capability. The primary objective is varied. It depends on which astronomer is on board and which instrument is installed on SOFIA. We have the capability to install several different kinds of instrumentation on board the telescope, and it depends on the objective of the flight as defined by the primary investigator. Sometimes we're looking at near planets, other times we're looking at galaxies that could be 30 or 40,000 light years away. The only thing normal about SOFIA is it's never normal. Everything is different every night. I'm the bus driver. I'm in charge of the aircraft. I'm in charge of aircraft safety. We work in conjunction with the team downstairs. This is where team cooperation happens. We're in charge of safety of the aircraft. The mission directors and the astronomers are in charge of the mission. It's actually perfectly safe. If you look at the length of the fuselage, the telescope sits in the back half of the airplane. We actually put a new pressure bulkhead just in forward of that telescope, so the front half of SOFIA is actually a normal airplane, and the back half is open to the atmosphere and completely unpressurized from takeoff through landing, the entire flight. There is no pressurization system back there. So basically our passenger compartment was made smaller to accommodate the telescope in the back half of the airplane. As far as from a pilot standpoint, SOFIA flies just like a normal 747, which is really incredible when you think about the size of the opening on the side of the aircraft that is housing the telescope. I can actually stand you on the main deck, tell you exactly when that door is opening, and you can't hear it, you can't feel it. There's no change in characteristics to the airplane. So my hat is off to the fluid dynamics guys that did their computations. When the door is open, when the door is closed, there is no difference in handling qualities of the airplane. Chase your dreams. If you want to do it, chase your dreams. And for NASA especially, math and science. I mean, it comes down to that, math and science. If you're not getting it, your teacher's job is to help you get it. Get the answers you need, get the help you need. That's what they're there for. They're not there to just assign homework, they're there to help you out.
Now that you've had a brief glimpse of SOFIA, here's how you can find out even more fascinating facts about the telescope on board.
Teachers, here's a chance to open your students' minds to the wide spectral world of infrared. Look for Cool Cosmos under the extension activity for this program on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer School.